Hello and welcome. With limits, we don't always have to construct ourselves a little table to see what the limit of a function is as it approaches a certain number. A lot of the time we can do it by inspection, or we can use certain techniques when things get a little bit trickier. For example, the limit as x approaches 4 of 3x minus 5. Well, we can see that the limit is going to approach 7, because 3 times 4 is 12 minus 5 is equal to 7. So in this case we can just plug the number in and we'll get the answer that we're looking for. Let's do another example. The limit as x approaches infinity of 7 divided by x. Well, we can see that as the value of x gets larger and larger, this result is going to get smaller and smaller. So it's very intuitive that the limit is going to be 0. So this was another case of finding the limit by inspection. Let's do a trickier example. What about the limit as x approaches infinity of 7x plus 9 over x minus 1? Well, in this case both the top and the bottom are going to get infinitely large if I plug in infinity. And I can't do infinity divided by infinity because I can only divide numbers, not symbols. So in this case I'm going to have to manipulate this function a little bit. The limit as x approaches infinity stays the same. And this is the trick. I'm going to leave the top the same, and I'm going to leave the bottom the same. But the limit as x approaches infinity won't change as long as I do the same to the top as I do to the bottom. So I'm going to multiply the top and the bottom both by 1 divided by x. Alright, so I'm going to actually expand 1 over x into both the top and bottom. So effectively here I'm multiplying by 1. And this should give me the limit as x approaches infinity of 7 plus 9 over x divided by 1 minus 1 over x. And now I can evaluate this limit, because a 9 over x as x approaches a very large number is going to tend to 0. So is 1 over x. So that's going to mean I'm going to get 7 plus 0 divided by 1 plus 0, which is equal to 7 over 1, which is equal to 7. So the limit as x approaches infinity of 7x plus 9 divided by x minus 1 is equal to 7. Alright, the limit as x approaches 2 of 3x squared minus 12 over x minus 2 is one we've seen before, and we did that originally by constructing a table and seeing what the number approaches as x approaches 2. But there is an easier way to find the limit for this, and it involves factorization. If I first factor a 3 out, I'll get 3 outside of x squared minus 4 divided by x minus 2. Now I realize that x squared minus 4 is a difference of 2 squares. It is a difference of x squared and 2 squared. So this difference of 2 squares can be broken down to x plus 2 and x minus 2, and the divide by x minus 2 remains the same on the bottom, and now I can cancel out the x minus 2's. So cancelling these out, I'm left with 3 outside of x plus 2. So the limit of this becomes the limit as x approaches 2 of 3 outside of x plus 2. And we can see that as x approaches 2, we're going to get 3 times 4, which is 12. Alright, with this one, as the limit approaches infinity of 6x squared plus 4x minus 2 over 3x squared minus 3, it's another case of multiplying the top and bottom by the reciprocal of the highest degree of x. So 6x squared plus 4x minus 2 over 3x squared minus 3, and I'm going to multiply that by 1 divided by x squared on the top and 1 divided by x squared on the bottom. So expanding that in, I will get 6 plus 4 over x minus 2 on x squared, 3 minus 3 divided by x squared. So this becomes the limit as x approaches infinity of 6 plus 4 on x minus 2 on x squared all over 3 minus 3 on x squared. And as x gets larger and larger and larger, these terms will go to 0. So I'll end up with a case of 6 divided by 3, which is equal to 2. So that's basically the gist of finding limits. And as with everything new in maths, it's a case of applying it repeatedly to internalize it and understand it. And once you get the hang of it and see the patterns, you'll find finding limits quite easy. It just requires a little bit of lateral thinking. In my next video, we're going to go into derivatives from first principles, and this is where knowledge of limits is essential. If you found this video useful, please give me a thumbs up. If you are currently studying math, please feel free to subscribe to my channel for future videos that may help you on exams or assignments. And as always, please feel free to ask me any question by commenting on any of the videos that you've seen. Thanks for watching, and I hope you've learned something.